Another idea we want to help introduce to you is how to find the absolute value of a complex number. And absolute value, what that meant was the distance to the origin. And so if I drew a point Z on the complex plane where it's over A units plus up B units such that it fits the form A plus BI, well, this distance, the point Z is, we're wanting to know how far away it is from the origin. And if we remember that the absolute value of that distance, or Z, is equal to the absolute value of A plus BI, and that would equal the square root of A squared plus B squared. And that's our distance formula. We're just looking at it in terms of the complex plane. So let me give you a couple examples of what this can kind of look like. So let's say I have some point Z, and this point Z equals 3 plus 4i. So the question I want to ask you is what's the absolute value of that complex number? So what I'll do is I'll use this distance formula in terms of the complex plane, and that will equal the A squared plus the B squared, and the root of all that out. So it'd be the square root of 9 plus 16 equals the square root of 25, which equals 5. I can draw a better 5 than that maybe. So the absolute value of that complex number is represented, or what it means is how far away from the origin it is, and it's a value or a distance of 5 units. Let's look at another example where I'm going to have Z equals -1 minus 2i. Again, that's a complex number that has both a real part and an imaginary part, but it represents one number in the complex plane, and I want to find out what is its absolute value. So I'll look at this number. I'll remember that its absolute value, its absolute value is the A squared plus B squared underneath the root. A is a -1 plus the B, which is a -2. -1 squared is 1 plus -2 squared is a 4, and that gives me the square root of 5. So the absolute value of that particular point is the square root of 5.